Good afternoon, dear students. This is Irshad. Welcome to class 9 ICSE Physics. In today's class, we are going to discuss numericals on motion in one dimension. I will help you understand the concept in a simple way. Let's start. This is the first question we are going to solve. A speed of car is 72 km per hour. Express it in meter per second. This is given here speed. So I will write here V equal to 72 kilometer by hour, that equal to 72 1 kilometer 1000 meters by hour 3600 seconds. Zero zeros get cancelled, so it is 2 5 ja 10, 2 8 ja 36. So finally we have 72 into 5 by 18 meter by second. 18 1 ja 18 4 ja. Then finally speed of equal to 4 into 5 meter by second. So V equal to 20 20 meter by second. Express 50 meter per second into kilometer per hour. We have seen 1 kilometer per hour equal to 5 by 18 meter by second. If 1 meter by second equal to 18 by 5 kilometer per hour, then speed V equal to 15 in place of meter per second. I will write 18 by 5 kilometer per hour into 18 by 5 kilometer per hour. 5 1 ja 5 3. Then V equal to 3 into 18 kilometer per hour. Multiplied will get 54 kilometer per hour. The next one. Express each of the following in meter per second. Each of the following. The first one is in kilometer per hour. Second one kilometer per minute. First one I will write. Here it is. 1 kilometer per hour equal to 5 by 18 meter per second. If we can divide 5 by 18, 5 divided by 18, you will get 0.277, etc. So simply we will write here 0.278 meter per second. And B, it is kilometer per hour. It is kilometer per minute. Then V equal to 18 kilometer na 1000 meter minute, 60 seconds. 0 0 get cancelled. 6 1 ja, 6 3 ja. Then V equal to 3 into 100, 300 meter per second. Arrange the following speeds in increasing order. So definitely we have to convert into the same system of unit. Then only we can identify which one is more, which one is less. So first one I do not convert here. This one I will convert, and this first one as it is same, 1 kilometer per minute. So 1 kilometer per minute equal to 1 into 1 into 1000 meters divided by 60 seconds. 0 0 get cancelled. That implies 100 by 6 meter per second. That implies divide 100 by 6, you will get 16.66. So what will you get here? 16.67 you will get meter per second. The next one, 18 kilometer per hour. 18 kilometer per hour equal to 18 into 5 by 18 meter per second. That implies 18 1 18 1 ja. So simply we will get here 5 meter per second. By comparing it, we have to arrange in the increasing order. First one is 18 kilometer per hour, comma 10 meter per second, comma 10 18 kilometer per hour, comma 10 meter per second. The last one is 1 kilometer per minute. Okay, this is the problems we are going to solve them one by one. A train takes 3 hours to travel from Agra to Delhi with the uniform speed of 65 km per hour. Find the distance between the two cities. This is the time, 3 hours. This is the speed. Distance need to find out. We have a formula. V equal to T by T. Distance by time. Speed is 65. T by time is 3 hours. That implies T equal to 65 into 3. 65 into 3. You will get 195. T equal to 195 kilometer. A car travels first 30 kilometer with a uniform speed of 60 kilometer per hour, and then next 30 kilometer with a speed with uniform speed of 40 kilometer per hour. Calculate the total time of journey, the average speed of the car. The average speed of the car. Okay, according to this question, distances are equal. Here 30 kilometers. The next one is a 30 kilometer. So let us take this is a V1 and this is the V2. Distance D1, D2. Then total distance D equal to D1 plus D2. Total distance D1 plus D2. Then D equal to 30 plus 30. That implies total distance D equal 60 kilometers. For average speed, we have a formula. When the body covers equal distances, so V average equal to 2 V1 V2 by V1 plus V2, that equal to 2 into 60 into 40 divided by 60 plus 40, that equal to 200 into 24 divided by 100. Two zeros will get cancelled. So V average you will get here. V average equal to 48 kilometer per hour. So this is the average speed of the car. Now need to find the time. So we have a formula for average speed. Average speed equal total distance by total time taken. So V average equal to total distance d by total time taken. From that I will write time t equal to total distance by average speed. Then time t equal to total distance 60 by average speed 48. It is in hours. Let's divide 60 divided by 48. We'll get 1.25 hour. 1.25 hour. So finally therefore time t equal to 1, oh, just multiply it, convert into minutes, into 60. So 1.25 into 60, you will get 75 mint. Very simple. So what is given in the question? Equal distances, d1 30 kilometers, d2 30 kilometers, uniform speed 60 kilometer per hour, 40 kilometer per hour. So when a body covers equal distances with a certain velocity, so certain speeds, the average speed can be written as 2 v1 v2 by v1 plus v2. The next one, a train takes 2 hours to reach the station B from station A, and then 3 hours return from station B to station A. The distance between the two stations is 200 kilometer. Find the average speed, the average velocity of the train. Total distance d equal to total distance d equal to 200, na 200 plus 200 plus 200 equal to 400 kilometers. A net displacement d bar equal to 200 minus 200 equal to 0 kilometer. Total time t equal to it is 2 hours, 3 hours. Total time is 5 hours. Therefore, the average speed v average speed equal to 400 by 5. 5 1 ja, 5 8 ja. So you will get here 80 kilometer per hour. Average velocity is 0. Why it is 0? Displacement is 0. A car moving on a straight path covers a distance of 1 kilometer due east in 100 meters, 100 seconds. What is the speed? What is the velocity of the car? What is the speed? What is the velocity of the car? Okay. So speed I'm going to find first. Distance given in kilometers. I will convert into meters. So this is the distance. Where is the time? Time. This is the time given. It is particularly east. This. So speed I'm going to find first. Speed equal to distance. So 1 kilometer is nothing but 1000 meters. Time is given 100 seconds. Two zeros get cancelled. So speed equal to 10. Speed equal to 10 meter by second. When we are going to talk about the velocity, we must specify due east. Due east. So velocity v bar equal to 10 meter per second due east. Due east. Okay, I think have you understood it? What is the difference? There is a speed is a scalar quantity which do not have a direction. Velocity is a vector quantity which has a direction. A body start from rest. Okay, good. And acquires a velocity of 10 meter per second in 2 seconds. Find the acceleration. Start from rest. Its initial velocity u equal to 0. Acquires a velocity. It is equal to final velocity. Of course, this is the time you will know. We need to find the acceleration. Acceleration formula we have a equal to v minus u by t. Here 10 is a final velocity. Initial velocity is 0 by time is 2. That equal to 10 by 2. Then therefore a equal to 5 meter by seconds. Full one and easy one. A car start from rest acquires velocity of 180 meter per second in 0.05 hour. Find the acceleration. Again here said rest initial velocity 0. 180 is a final velocity. Time given 0.05 hours. So first I will take a time. Time equal to 0.05 hours. Convert into seconds. So it is 3600 seconds. Reply 0.05 into 3600 will get 180 seconds. 180 seconds. Acceleration. Just now we have seen a formula. A equal to V minus U by T. That equal to final velocity 180. Initial velocity 0. Time is 180 seconds. Therefore, acceleration will get 180 by 180. 180 180 will get cancelled. A equal to 1 meter by second square. A body is moving vertically upward. Its velocity changes at a constant rate from 50 meter per second to 20 meter per second in 3 seconds. What is its acceleration? And this is the initial velocity, final velocity, and time. It acceleration A equal to V minus U by T. That equal to V value is 20, A is 50 by 3. That equal to minus 30 by 3. Then you will get here A equal to minus 10 meter by second square. So a body is projected vertically upward. Direction of motion is opposite to the acceleration due to gravity. So the velocity is gradually decreasing. A toy car traveling, a toy car initially moving with uniform velocity of 18 km per hour comes to stop in 2 seconds. Find the retardation of the car in SI unit. This is the initial velocity of the car, u it is. And he said that it comes to rest, stops. So final velocity equal to 0, time equal to 2 seconds, time equal to 2 seconds. Then acceleration can be written as A equal to V minus U by T. Acceleration is V minus U by T. Final velocity is 0. Okay, before that, I will convert the initial velocity 18 km per hour into meter per second. I will write here U equal to 18 km per hour. 1 km per hour equal to 5 by 18 meter per second. 18 one ja, 18 one ja. So initial velocity U equal to 5 meter per second. Then A equal to final velocity 0, initial velocity 5, time is 2. A equal to minus 5 by 2 units meter by second square. A equal to minus A equal to divide 5 by 2 is equal to 2.5 5 meter per second square. 2.5 second square. The next one. A car accelerates at a rate of 5 meter per second square. Find the increase in its velocity in 2 seconds. This is the acceleration here given, time period given here, and we have to find increase in the velocity, I mean delta v. Formula is a equal to delta v by t, where delta v is a increase in velocity. Delta v equal to a into t, where a is 5, time is 2, then 5 to ja 10, 10 meter per second. So this is the increase in velocity. Velocity increases 10 meter per. A car is moving with a velocity of 20 meter per second. The brakes are applied to retard it at a rate of 2 meter per second. What will be the velocity after 5 seconds after applying the brakes? In the question, this is the value of u, initial velocity. This is retardation, he said that. So this is the a, this is the time t. Now we need to find the final velocity v equal to. And then he said that it is retardation, retard. So a will write here minus 2, a equal to minus 2 meter by second square. Same formula, a equal to v minus u by t. Otherwise we can write the kinematic first equation, v equal to u plus at, where u is 20 minus 2, time is 5 seconds, that equal to 20 minus 10 minus 10, and v equal to 10 meter per second. The next one, a bicycle initially moving with a velocity of 5 meter per second accelerates for 5 seconds at a rate of 5 at a rate of 2 meter per second square. What will be its final velocity? So the value of u is 5 meter per second, the time, the acceleration a. Same formula once again we will use here, is v equal to u plus at, v equal to u is 5 plus a is 2, it is accelerate not decelerate, so I did not take a negative sign. Time is 5 seconds, we will get 5 plus 10 equal to 15 meter per second. This is the velocity. A car is moving in a straight line with a speed 18 km per hour. It is stopped in 5 seconds by applying the brakes. Find the speed of the car in meter per second. The retardation, the speed of the car after 2 seconds of applying brakes. So it is a initial velocity u This is the time period t. Let's find one by one. First is the speed of a car in meter per second. Yeah, as we know that u equal to 18 kilometer per hour. 18 into 5 by 18 meter per second. 18 get cancelled. So we have u equal to u equal to 5. Retardation is said that let us consider the body finally come to the rest. Then we will write here acceleration a equal to the velocity v equal to 0. Acceleration a equal to v minus u by t. A equal to 0 minus 5 by 5. So a equal to minus 1 minus a equal to 1 meter per second square. Okay, for third one, given the time here, time equal 2 seconds, and what is the velocity after 2 seconds? We found the acceleration also. So v equal to u plus at. V equal to the 5 pound minus 1 into time 2. So v equal to 5 minus 2. V equal to 3 meter per second. The next one. Okay, thank you. So finally, today we have completed motion in one dimension. First exercise. In the coming class, definitely we will solve motion in one dimension exercise B numericals. Thank you and take care of you.